Hello, everyone. My name is Noeloikeau Charlot, and I work on analog-enabled cryptography with my advisor, Daniel Gauthier, at The Ohio State University, and some of our close collaborators in Dominic Forte's group at the University of Florida, namely Rabin and Fatima. Let's dive right in. So I said we work on analog-enabled cryptography, and to us, that means a particular system known as the chaos gate, and that's short for chaotic logic gate. And basically, it's a circuit that generates unpredictable fluctuations in voltage and electricity. And it's a circuit which is very small. It's composed of nanometer wide MOSFETs that are or transistors, which are coupled to each other. And what we use it for is, say, obfuscating the electronics around it because it generates this complicated, unpredictable pattern. It makes it hard for things near it to be spied on, basically. And so this is an example of a cryptographic application. And something we also do that I'll get to maybe at the end is we train artificial intelligence to maximally optimize the design of this chaotic system. And so when you go in and you build these transistors and you hook them up, sometimes they'll be chaotic and sometimes they won't be based on different properties of the system, like how much voltage you give it. And so what we want to do is we want to get as much chaos as we possibly can. And we want to do that because, again, we want to create unpredictable, obfuscating sort of shields to prevent people from spying on, say, classified computer chips. And the way that artificial intelligence comes into this is we simulate many, many thousands and thousands and thousands of these systems, but we vary, say, the width of some of the MOSFETs, or we vary some of the voltages, and that will cause the system to dip into and out of chaos. And what we're trying to do is create basically the most chaotic system that we can to further enable cryptography in the analog domain, which means that we have a continuous fluctuation. So that's analog-enabled cryptography. I certainly think it's interesting. I hope you do too, and I'd be happy to talk about it more if you feel like reaching out. Thank you.